Today we're tackling the Cisco 300-110 Exam Mastering Enterprise Wireless Design. Let's jump straight into the questions.
Yeah, let's do it. There's a lot of RF magic to unpack for you guys today.
Okay, so first up, say an AP has a wired connection back to the network. What role must be set before changing its mode?
Tricky one to start.
Yeah, I mean, my instinct is to pick bridge or maybe local mode, right? They're just the most common ones that pop into my head.
Ah, I see why. But it's a trap. You're falling into this availability bias like thinking of modes instead of roles.
Oh, wait, roles?
Yeah, the actual answer here is RAP, or root access point.
Mm.
In the real world, think of the RAP as the mainland dock.
Gotcha. And the MAP, the mesh access point, is like a boat connecting back to it.
Exactly. You absolutely have to define that RAP role in the AP with the physical wire before you change how it reaches the network.
Okay, so if defining that root access point role is crucial for an outdoor mesh, what happens indoors? Like at a remote branch that lacks a wired connection but still needs local switching.
Right. No wire at all.
Yeah, so I'd usually just throw standard Cisco Flex Connect at this, right? It handles local switching beautifully.
Well, I get the logic, but I got to stop you there. Standard Flex Connect still strictly expects a physical wire.
Wait, really?
Yeah, it just determines where the traffic is switched. Since we have zero wired backhaul, the answer is Flex+Bridge.
Oh, okay.
Imagine setting up a temporary pop-up clinic. You need that enterprise authentication and local switching, but you need to do it entirely without pulling physical cables.
So you're bridging the air gap and flexing the switching.
You got it.
That makes a lot of sense. Speaking of airspace, question 3 dives into designing a high-density campus WLAN that needs low interference. My brain immediately says 80 megahertz channels.
Bigger is faster.
Right, exactly. Hear me out. If I have hundreds of modern laptops, shouldn't I give them an 80 megahertz pipe so they can transmit faster and get off the air?
It sounds super logical, but here's where it gets dramatically counterintuitive.
Oh.
In high density, the answer is actually 20 megahertz channels on both the 2.4 gigahertz and 5 gigahertz bands.
Really? Just 20?
Yeah, think of a crowded cocktail party. If everyone is using 80 megahertz channels, it's like everyone yelling across the room at the same time.
Oh, total chaos.
Right. Shrinking to 20 megahertz channels is like breaking the room into smaller, quieter tables. You get way more frequency reuse, which means far less co-channel interference.
Shrinking the tables, I really like that. And I guess you can't even begin to do capacity planning without making that choice first.
Absolutely not.
Which leads to our next scenario. We have 100 users needing 1 megabit per second each. Each 5 gigahertz channel gives 20 megabits per second before overhead. How many channels do we need?
Oh, I see. Candidates guess trap answers like 10 or 20 here all the time instead of actually calculating it.
Yeah, exactly. Don't guess. It's simple arithmetic. 100 users multiplied by 1 megabit per second is 100 megabits per second total demand.
Right.
Divide that by the 20 megabits per second channel capacity, and your answer is exactly 5.
The math doesn't lie. Nope. Okay, let's take this capacity outdoors again. Autonomous trucks using Cisco IW3702 APs, as WDBs need fast roaming and enterprise security, but absolutely no AP certificates.
No certs. That's the kicker.
Right. Now, I'd argue for EAP-PLS because it's just the gold standard for security.
It is highly secure, sure, but EAP-TLS requires certificates. That's the trap.
Right.
The correct design here is a WGB in mobile station mode with EAP-FAST and a .1Q capable switch. EAP-FAST uses PACs instead of certificates for secure tunneling.
Oh, so no certs needed.
Exactly. In the real world, this is how latency-sensitive warehouse forklifts seamlessly roam across zones without dropping connections to re-authenticate constantly.
Got it. Avoid the certs when they aren't there. Okay, here's a scenario straight from the Cisco DNA Center console.
Let's hear it.
We're looking at a WLAN config for an SID called EDU Lecture Hall Primary. Band select is enabled, and the RxSOP threshold is set to -75 dBm. What's reducing high channel utilization from rogue APs here? A lot of folks jump at DFS detection, which is a huge trap. DFS detection is strictly for radar avoidance, not rogues. The answer here is RxSOP, which stands for Receiver Started Packet.
Okay.
By setting it to -75 dBm, you are literally telling the AP's radio to drop and ignore any packets weaker than that threshold.
Oh, wow. So it's like giving your AP noise-canceling headphones.
That is exactly what it's like. So it doesn't waste airtime processing distant rogue chatter in a packed lecture hall.
I love that noise-canceling analogy. Last question, and it builds right on that tuning concept.
Okay.
A university needs distinct radio settings for separate high-density zones. AP profiles seem like the most logical choice to apply those settings, right?
Close, but AP profiles are just too general for this. They handle things like the AP name or the primary controller.
Oh, so what is it then?
The answer is RF profiles. That's what allows you to configure entirely different radio resource management behavior like power levels and thresholds
Hmm.
for a quiet, dense library versus a massive open stadium.
All right, the exam simulator is off. Let's step back and map out our strategic checkpoints.
It's funny how all of this connects for you guys, right? You really have to build from the foundation, like understanding wireless mesh AP roles, REP versus MAP before doing anything else.
Exactly. And from there, solving complex edge cases using Flex+Bridge mode for wireless backhaul and local switching.
Right. And you can't even begin that math without proper high-density WLAN channel planning.
Which ties perfectly into WLAN capacity planning and per-user throughput calculation.
Right. We can't forget about Workgroup Bridge design and roaming for those autonomous trucks either.
Plus the fine-tuning tools to manage the actual airwaves, like RxSOP for high-density RF optimization.
Yeah, and applying RF profiles for different coverage zones.
That covers the entire blueprint perfectly.
It really does. But, it leaves you with an interesting thought.
What's that?
If we have to manually tune all these variables today, how will AI-driven networks change the role of the wireless architect tomorrow?